So essentially today, like I said, in section 6.4, we're talking about nth roots. And what we're going to be doing is simplifying some square roots. But instead of kind of worrying about the graphs of a square root, like we kind of saw in the last couple sections, or instead of worrying about some specific values that we're going to get, we're dealing with now variables underneath our square root, okay? And we're going to see how we're going to be able to simplify those and not really worry about getting like an X and Y value and plugging things in, but just kind of breaking them down as much as we can and simplifying. All right. The biggest thing that we need to kind of take into account, and the reason that we have this note there at the top, is in order to simplify when we're dealing with radicals and variables underneath our square roots, we look to see essentially how many groups of that variable we can make, right? Or taking that root of the variable and the constants and everything, we need to take a look at what's called the index. All right. And the index essentially is just the number that is on the outside of your square root. So what root are you taking? How many groups are you trying to break something up into, right? And that's essentially what taking the square root or the third root or the fourth root is, right? So if you take a look here, it says like reminder, a square root has an index of 2. It's never written there, but this index, this number, like I just explained, well, how many times am I breaking this down? Okay. Are there any questions about what an index is or kind of what our plan is for how we're going to solve some of these problems and what we're doing, just simplifying? Okay. Let's take a look at example A here. We're taking the square root of x squared. Now, again, if you need to, when the square root's by itself, if you want to write that index in, it's going to be helpful for you because we're going to see how we can simplify this for moving forward. So make sure that you kind of always write that in if you need to make sure you know how many groups you're breaking things up into. When we talked about simplifying before, though, we should be able to answer this question, right? If we have something squared and we take the square root of it, what does that do? Kind of cancels it out, right? And then what would I be left with here? Just x. We've seen something like this before. When we take the square root of something squared, we say that it cancels out in a way, and we're just left with x. And we've kind of always just assumed that that was the case, right? But we never understood why that's what's going on, right? First question is, what's really the power of this variable here? This is x to what power? So 1, right? So this is x, or x to the first power. Well, my question for you is, what operation can we do? Maybe between these 2's, the 2's that are on the inside, so this x to the second power here, and the 2 that's my index on the outside, what operation can I do to give me 1 between each of those 2's? Division, right? Think about our operations. If we did addition, well, 2 plus 2 gives me 4. Well, that's not my power here, right? 2 minus 2 gives me 0. That's not my power. 2 times 2 gives me 4. That's not the power. If I divide this 2 on the inside by the 2 on the outside, that's what gives me my x to the first power. And that's what we're going to have to use and do for each of these problems to kind of simplify and understand what we're going to be left with after we take the square root or the third root or the fourth root, depending on what it is, right? So now we kind of have an idea of why it is that they quote unquote cancel out. It's because we're dividing the variable and its exponent by the index, all right? So our answer here is just x, or x to the first. Does anybody have any questions about that idea? Okay. In this margin over here, I'm just going to formulate some steps for us to kind of keep glancing at as we're going through these problems. The first thing that we need to do is identify what that index is. So identify the index. Am I taking the square root? Am I taking the third root, the fourth root, so on and so forth? Because we're not always going to be dealing with just square roots. So we want to identify what that index is. The second step would be to take the root of any constant term. So take the root of any constant term. In that first example, as you're kind of writing down, just keep an ear out for this. First example, we didn't have any number that's being multiplied by the x squared, right? That's not always going to be the case. Sometimes there will be a constant there or a coefficient, is another term that we always use, that we might need to break down. And what we do is we take the root of that. So if it's telling me the index is 2 or 3, we take the square root or the cube root of that number and then work to the variables next, right? And we're going to see some examples of that as we progress through our own practice. But let's make sure that we remember to take the root of that constant term before we do anything else, right? If it's not there, we move on to the variables, which is our third step. And that's to divide the exponent inside the root with the index. So take whatever that exponent is, like we talked about, those 2's on the inside and 2 on the outside. We divided those to find our simplified answer, right? So we divide the exponent on the inside with the, inside the root with the index, which is that number on the outside. Okay. Any questions about those steps or the first example that we did? Everybody good? Okay. Let's take a look at part B. Let's go through our steps here. What would you say is the index in part B? So what's that number that's really on the outside there? What's that? 2, right? If I'm taking the square root, my index is 2. And like I said, if you need to kind of write that in to help you out, you can do that. My second step would then be to take that second root or the square root of any constant terms. Well, are there any constant terms inside my square root here, or is it just variables and exponents? There's no constants, right? So I move on to step 3, which is then to divide the exponents inside the root with the index. So in other words, I'll have x to the 6 divided by 2 and take it variable by variable. Notice that I have 2 in there. I'll have y to the 8 divided by 2. As we progress through problems, you're not going to have to write this step out. You can kind of just go through and simplify. What's 6 divided by 2 going to give me? 3. So I have x to the 3rd power. And 8 divided by 2 is going to give me what? 4. So I have y, to the 4th power. And then that would be my simplified answer. Any questions about that example? Okay. Notice that in part C right now, I have a fraction underneath my square root, right? First question we have is, what's the index? So if it's a square root, the index is what? We've seen this a couple times now. What's that? 2. Good. If there's a fraction, if you're taking the square root of one term divided by another, it's the same thing as taking the square root of the numerator, so 6a to the 4th, and the square root of the denominator, b to the 10th, separately. And I would encourage you to write it out this way so you're not thinking too much about simplifying in one step or anything like that. You're taking the square root of the numerator and then the square root of the denominator and simplify those kind of on their own. All right, then combine them for your final answer. Any questions about that idea? So the square root of a fraction is the same thing as the square root of the numerator divided by the square root of the denominator. Well, we've identified our index, which is our first step. We said it was 2. And I'll write that in case we need it. Take the root of any constant term. In my numerator, notice that I have a 16 now underneath my square root. So I have to worry about, or work with, I should say, instead of worry about, I have to work with taking the square root of that 16 first and then dealing with anything with my variables. Well, what's the square root of 16? 4. So in my numerator, I'll have a 4. Now I'll simplify with the variables the way I have before. What's the square root of a to the 4th? So what do I have to do with that 4 and the 2 on the outside? Divide them. So I'd be left with what? 4a squared. Good. That comes from a to the 4th divided by 2, or a to the 4 over 2, which is 2. And I took the square root of that 16. So make sure that you always worry about the constant first, then do anything with the variables. Are there any questions about that? How would you simplify the denominator? What's that going to become? B to the 5th. Good. It's b to the 10 divided by 2, or b to the 5th power. Okay. Any questions about that example? So we've seen something that's just a variable. We've seen multiple variables, and now we've seen some examples of not only a fraction underneath the square root, but also dealing with a constant term as well. Everybody good? The next example, so part D. What's my index in part D? What changes here?
There's an a minus 1 in parentheses.
Okay, so something that you notice inside the root is that it's a quantity a minus 1. So you're seeing some operations now. That's really not going to change our steps. Something else that we noticed. Right, now the index is 3. So careful now that I'm not taking the square root, I'm taking the cubed root, or the third root of whatever's inside my parentheses. Now, as we said, inside is the a minus 1. We still do anything with constant terms. Well, is there any constants inside my square root? So there is a -1, but that belongs to this whole expression here, right? So is there anything like, is there a coefficient at all or anything on the outside of that? No, right? So now I just divide the exponents on the inside with the ones on the outside. This really becomes the entire quantity a minus 1 to the 6 divided by 3. Well, what's 6 divided by 3? 2. And my final answer is a minus 1 squared. So anytime that you see an expression or something that's separated with parentheses there, you do those individually and you can leave it as that expression raised to the power. So don't overthink like, oh, I have to do a to the 6 divided by 3 and then -1 to the 6 and then divide that by 3, right? That's a place where people can make mistakes. Just divide the exponents with the index. Okay. Any questions there? All right, let's take a look at example E. What would my answer be for example E? We're following along with the same steps we have from before. X to the 3rd and then y. Good. Right? That comes from x to the 9 divided by 3, which gives me the 3. So that's how I get x cubed. And then y to the 3 divided by 3. Well, 3 divided by 3 gives me 1. So I just leave it as x cubed y. Any questions about that example? Seems pretty easy, right? Nothing too crazy. Example F is a little bit different too. What do we notice about example F?
It's negative.
There's a negative. Now, before when we were talking about just square roots, right? And we were solving them and simplifying. Remember when anytime there was a negative under our square root, we had to take an I out and simplify it normally. if your index is an odd number, you do not have to worry about anything imaginary, right? Let's think about maybe a number I can multiply together by itself 3 times that it's going to give me negative 27. Okay, so careful. So that's if I did negative 9 times 3. I'm looking for a number that I'm raising to the third power. So that's another thing that people get tripped off on, and that's no fault to you either. A lot of people make that same mistake. We think about, oh, well, what can I multiply by 3 to give me negative 27? We have to think about, well, what number do I raise to the third power to give me negative 27? So it's a little bit different. Anybody have any ideas? So not positive 3, negative 3, right? That's what's going to allow us to have a negative under our square root. What's negative 3 times negative 3? What's that? Positive 9, right? Because negative times negative gives me a positive. And then what's positive 9 times a negative 3? Negative 27, right? So this exercise here allows us to see that we can get a negative as a final answer when we're taking a root of a negative number, right? So what we just did was identified the index, which is always our first step. But then we took the root of that constant term. The cubed root of negative 27 is what gives me the negative 3. Now I need to just worry about that variable. How's that going to simplify? What's the cubed root of a cubed? Just a, right? So just taking the 3, dividing it by the 3 on the outside. So I have a to the first, or just a. So my answer is negative 3a. All right. Any questions about that example? So you can have some negatives under your square or under your root if the index is odd. If it was even, then you'd have to work with taking an I out and simplifying it that way, worrying about plus and minuses and all that stuff. Yeah. If there's a negative number underneath your root and it's an odd power, you can simplify it normally, just like we did there. What would be my answer for part G? This one should be pretty straightforward. X squared, right? X to the 8 divided by 4, or just x to the second power, so x squared. And we didn't really address it in part G because that was a little bit more of an easier problem. But what do we notice about this whole row here? What's the index? 4, right? So always be aware of what the index is because that's going to change how we simplify, right? We're not dealing with the square root or the cubed root. Now we're dealing with the fourth root of something. So like if I go to part H here, this example, I have to worry about the index, which is 4. Then I have to worry about any constant terms. Well, what's the fourth root of 16?
2.
2. So careful again. I'm not taking a number and multiplying it by 4. I'm taking a number and multiplying it by itself 4 times. So at home and in here, we both said 2, right? And another thing you can do, if this helps, take each term inside your square root and write it this way: the fourth root of 16 times the fourth root of x to the 12th power. So that way you know you're kind of breaking it up and doing it step by step if you need to do that, right? As you progress through and get more practice with this, it should be second nature as to what you need to be doing. But just in case, so we said this was 2. And then how would I simplify this over here? So the x to the 12th, and then I'm taking the fourth root of that. How does that simplify? Right, so x to the 12 divided by 4, which is what? Right, just 2x cubed. Okay. Any questions about that example? Everybody at home doing all right? Any questions at all about anything that we've done so far? Okay, let's take a look at this last example here on the front page. So I have the fourth root again of 81x to the fourth y to the 16th. Think back to what we did in part C here with the square root, but I was still doing it with a fraction. Can do the same thing even if the index changes. So I can think of this as the fourth root of 81x to the fourth. Think of this as the fourth root of y to the 16th. What is the fourth root of 81? 3. 3 times 3 gives me 9, times 3 gives me 27, times an additional 3 gives me the 81. So it's going to be 3. How do I simplify the fourth root of x to the fourth? Just x, right? Divide the 4 and the 4, that gives me x to the first power. Are there any questions so far? In the denominator, how's that going to simplify? Y to the fourth, good. I don't have any constant terms to worry about. I know what my index is. It's the same as the numerator. So I just move on to the variables at 2, 16 divided by 4, and that gives me y to the fourth. So my final answer here, 3x divided by y to the fourth. Are there any questions about any of the examples we've covered so far? Anything from this first page, the process in general? Anything that I can clear up? Okay, so make sure you're going through your steps, identify the index, take the root of any constant term, and then divide through the exponents from the inside of the root with the number on the outside, which is our index. All right. On the back of this sheet are practice problems. This worked pretty well in the last class, so I'm going to do it again for this class. What I'm going to do is kind of split the room up in here and split you up, for those of you that are at home, into some breakout rooms so you can work through these problems, all right? We'll split the room up, U4 over here, so these two rows here. So U4, just work on numbers 1, 2, and 3. All right, so this group of 4 is responsible for 1, 2, and 3. This group of 4 on this side of the room, responsible for 4, 5, and 6. Okay. Those of you that are at home, I'm going to put you in 2 breakout rooms. Okay. Breakout room number 1 is responsible for 7, 8, and 9. All right. So let me put that in the chat just so we're all aware. So group 1, you guys have 7, 8, and 9. And we'll have somebody from that group share out their answers. And then group 2 will be 10, 11, and 12. Okay. I'm going to open those rooms up now. So make sure that you join them. You guys can work together, collaborate. One thing that I forgot to mention earlier too, especially with simplifying some of these roots with higher indexes and things like that with the constant terms, it's okay to use a calculator. All right. So if you're not 100% sure what the cubed root of 8 is or the fourth root of 81, right? I'm fine with you using something to kind of help you along with that process. All right. So that's fine. With that being said, so those of you that are at home, open up the breakout rooms, make sure you're working together, make sure you have somebody that's going to share out their answers. All right. And then we will move on from there. Hold on 1 second, sorry. Move on from there to go over these, and then we'll be done with the day. All right. So those of you that are at home, join the rooms. Those of you that are in here, make sure you're taking care of the problems that you are assigned. And we'll reconvene in about 5 minutes or so. Yeah.
So this one's right. This one's right. Make sure you take it. So you take the fifth root of 32. So you have to do it. Right. So it's good shift. So that's out of that. So shift. And then this one over here. Down other. So type in 5. So 32. So they're using that in order to So don't worry about what's inside. So that's just that's all I do. So all that. Any good ones. So it's this screw. And then that takes care of that. There you go. Square root. So that's let's get this one. So that's if you have that better that, I'll tell you.
Take another minute or so to wrap up the problems that you need to share out on, and then we will go over as a class in about a minute or. Okay. So everybody that was at home should be back into the main room by now. Those of you that aren't here, obviously, should be probably wrapping up your questions also. So somebody from this side of the room, or a couple of you if you want to, help me out with the first three problems. We're just going to kind of go through this quickly and talk about the answers and then move on, all right? So for number one, what was an answer? 9x squared, good. Take the square root, that's my index, so it's 2. Square root of 81 gives me 9. X to the 4th divided by 2 gives me that squared, so my answer is 9x squared. Number 2, 11y to the 5th. Square root of 121 is 11. Y to the 10th, my index again is 2, so I do 10 divided by 2, that gives me y to the 5th. So my answer is 11 y to the 5th. And then example 3, what's that? 2g squared. Excuse me. So the cubed root now is my index. So my index is 3. Cubed root of 8, a number I can multiply together 3 times to give me 8. Well, 2 times 2 gives me 4, times an additional 2 gives me the 8. And then I have g to the 6 divided by 3, which gives me the g squared. Any questions about numbers 1, 2, or 3? Okay. Now this side of the room, 4, 5, and 6. What do we get for 4? Good. A to the 4th power, b to the 5th power. So 12 divided by 3, that's how I get a to the 4th. My other variable b is b to the 15th divided by 3, well, that's b to the 5th. So my answer here is a to the 4th, b to the 5th. Good. What do we get for 5? To x, good. Y to the 3rd. The 5th root of 32 is 2. You multiply 2 together by itself 5 times, or you take 2 to the 5th power, you get 32. X to the 5th divided by 5, well, that's x to the 1st, and then y to the 15th divided by 5, that's y cubed. So that's what gives me that answer there. And then what do we get for number 6? How about one of the gentlemen on this side of the room? What do we get for 6? X minus 9, good. Right, if we have that quantity in there, we don't have to worry about anything that's inside my parentheses. I just do the exponent divided by the exponent, or the index. So I have x minus 9. Nice job. Any questions at all about 4, 5, or 6? All right. Somebody from that first breakout room at home, tell me about your answer for number 7. What did you get for number 7?
Okay, so I don't know if I'm correct or not, but I got 8x to the 3rd over 3.
Okay. So very, very close. It's not 8, it's 4x to the 3rd over 3. So if you take 8 and multiply it by 8, you get 64. So that would have been like the square root. 4 times 4 gives me 16, times an additional 4 gets me to the 64. So that's why it's 4. But everything else you simplified correct. So you did the x to the 9th divided by 3, that gave me the x cubed. And then you did the cubed root of 27, which gave me the 3. So this is my final answer. So just be real careful with that constant term, right? Like I said, if you need a calculator to kind of help you out and simplify, that works. Does that clear up number 7 though, in case anybody had any questions?
Yeah.
Okay. What about an answer for 8?
I don't think any of us got an answer for number 8 because we got like stuck on it, and pretty much I didn't really understand it.
Okay, so it's a little bit of a curveball because it's a constant term, right? And we've been dealing with a lot of variables, so we're kind of just going back to simplifying a cubed root. What were you gonna say? Yeah, decimal's fine. 0.2, good. If you take 0.2 and you multiply it together 3 times, well, 0.2 times 0.2 times another additional 0.2 gives you the 0.008. All right. Everybody good with that? Okay. What about example 9 here? Somebody from that first breakout room at home, example 9.
I got x squared and y cubed.
X squared, y cubed. Good. X to the 8 divided by 4. Well, that's how I get the squared. Y to the 12 divided by 4. That's how I get the cubed. So I have x squared, y cubed. All right. Any questions, 7, 8, or 9? Okay. And then real quickly, 10, 11, and 12, that second breakout room. Here's some answers for number 10.
50x.
Okay, careful. Square root of 100.
Square root of 100 would be 10x then.
10x. There we go. So 10x. Number 11.
5x cubed.
5x cubed. Good. Because you have the cube root of 125. Well, that's 5 times 5 gives me 25. Times an additional 5 gives me the 125. And then x to the 9th divided by 3. That's how I get the x cubed. And then number 12.
4x to the 4th.
4x to the 4th. Good. So the square root of 16 gives me the 4th. Then x to the 8th divided by that index of 2 is x to the 4th. Any questions about 10, 11, or 12, or anything from this practice? Okay. So that's it for the section 6.4 notes. Like I said, pretty short, very straightforward. Your homework for tonight is on page 410, doing numbers 13 through 31 odd. All right. So don't do all of them, just the odds. On your homework, don't worry about any plus or minus here. All right. Just kind of go through and do the problem that's given to you. Notice that some of them have some quantities in there. Some of them are just a variable raised to an exponent. Some of them have some constant terms. So it's a good mix of everything that we saw today. So make sure that you get that done. When you come in tomorrow, we'll go over that and then continue with section 6.5. All right. But other than that, just make sure you get the assignment done. Question? What's that? I'm sorry. So yeah, you just keep the negative on the outside. So you simplify normally, just keep the negative there. Any other questions about the assignment? Okay. Make sure you get that done. Other than that, have a great rest of your day, and I will see you all tomorrow. Those of you that are in here, just wait for the bell to ring. Those of you that are at home, you go ahead and sign off.
Have a good one.
You too. Take care.